Hello and welcome to today's class. For this class, we'll be looking at the derivation of cantilever beam with point load not at the free end. So how do you derive the slope equation and the deflection equation for a cantilever beam with point load not at the free end? For this class, we're looking at the derivation of the slope equation and the differential equation of this one here, and also using this idea to solve some past question. So for this concept here, we are using what we call the area moment method, please. So I'm using what we call the area moment method. You know, we have double integration method, we have area moment method, and there's one type of method too. So, but basically, we're looking at area moment method of derivation of cantilever beam with point load not at the free end. First, my first task says to what? Mask out diagram to illustrate a cantilever beam with point load not at the free end. So it means that from here now, I'll be having a cantilever beam somewhere here. A cantilever beam, as you can see, something of this nature. Sorry. So with point load not at the free end, not at the end here. So you know we said we have the derivation for cantilever beam with point load at free end. So for this one here, we know that y is equal to WL cube over 3EI, and we said slope equation C WL squared over 2EI. This is for cantilever beam with point load at free end. Now, today's class, we're dealing with cantilever beam with point load not at the free end, right? So this is what I'm having here. All right, proceed from diagram here. So from here to here is obviously my entire length L. Call this point here, call it L1. From here to here, call it L1, and call the distance from here L1 minus L. Distance from here to here, right? So distance from here down to this point here, call it L. Call it L1, call it L minus L1. I have this one here. So to draw out my deflection, I'll have something of this nature. I'll take this point here down this way, right? So I'll come to this point here, and I'll take it down this way, right? And I'll make sure they meet each other down this way. So I have this. I'll pick a center of gravity, that's G, a point here, call it 2 over 3 L1. So I have it as my center of gravity here. Next up, let me pick it, let me do this way. G. All right. At this point, I call it WL1 over EI. So this is like the diagram you need to note, you need to memorize, or perhaps practice, so that I can know, so you know how to mask out the diagram. So know how to draw this diagram here. So when you are done drawing this diagram, what next? What's your next task? From here now, my next task will start with what? The slope equation and the differential equation. We said when it comes to slope equation, the idea is you are using, when it comes to slope equation, when we are using double integration method, slope becomes C, deflection becomes Y. But when you are using area moment method, slope becomes A. So at this point here, calculate for slope equation. So calculating for slope equation, what do I get? We know that slope equation is represented with A. So A is equal to 1 over 2 times, observe please, 1 over 2 times, from here to here is L1. So times L1 times the height from here to here is WL1 over EI. So I'll have WL1 over EI. At this point here, multiply through. My slope equation A is equal to 1 times L1 times WL1. That gives WL1 squared all over 2 times EI gives 2EI. So this becomes my mathematical expression for calculating slope equation for a cantilever beam with point load not at the free end. So this is my mathematical expression for it. Note that we said the SI unit for what is it called, for slope equation. So for slope equation, when it comes to area method, is what is in radian. Radian, right? So let's derive the last equation called deflection equation. So calculating for deflection equation. How do you get your deflection equation? The task is simple. We say when it comes to deflection, that's y. We all know it's y. So what's y? Y is equal to the slope equation times the center of gravity. So now, without wasting much of our time, just note this one, that when it comes to deriving the slope equation, deflection equation for a cantilever beam with point load at the free end using area method, I'll have that y is equal to, start with this one here, WL1 squared over 2EI plus WL1 cubed over 3EI into L minus L1. So this becomes a mathematical expression for a cantilever beam with point loading at the free end. So this becomes a mathematical expression for the deflection equation for a cantilever beam with point load not at the free end. All right. Let me explain something. How do I identify questions based on this? If you see a question, how do you know that question is talking about cantilever beam with point load under the free end? In the question, you'll be given two lengths. That's the concept. The difference between this one and other concept I'll be discussing is that for question of this nature, of this one here, you'll be given two lengths. You'll be having two lengths in the question. So when you have two lengths in the question, don't stress. Apply the concept of what derivation of apply the concept of cantilever beam with point load not at the free end. Let's use this idea we have just understand now to solve some past questions, and let's see what we can do. Example says that a cantilever beam of span 3.6 meter carries a point load of 21 kilonewton at a distance of 2.9 meter from the fixed end. What are the value of the slope and deflection at the free end of the cantilever using moment area method? If the flexible rigidity of the beam section is 9 times 10 to the power 12 Newton per meter squared. Let's get this done. First things first, your first task in science is to list out the given parametric unit. What are you given? So first things first, there I'm given that a cantilever beam of span 3.6 meter. So that's my length. L 3.6 meters as my first length. There carries a point load of 21 kilonewton. That's my weight, W. 21 kilonewton at a distance of 2.9 meters. So that's my L1 now, 2.9 meters for a fixed end. All right, what are the value for slope equation? So that's A, slope equation, and deflection, that's Y, is unknown, and deflection equation at the free end of a cantilever using area moment method. So I'm having A and Y. If they have said using double integration method, I will have put C here and then Y. So that's like the idea. All right, I'm given that flexible rigidity, that's EI, is equal to 9 times 10 to power 12 Newton per millimeter squared per se, millimeter squared. So my first task now is that let's find the what's it called, the slope equation and deflection equation for this question here by applying these two formulas, right? So now before I move on, I'm seeing my EI in terms of millimeter, and I'm seeing my what's it called, I'm seeing my EI again in terms of Newton. So now the question now is that, am I converting? Of course, yes. Now, what's the reason why we convert in science? The reason is that we want to make sure that every parameter has the same unit, right? Are uniform. So let's say this one is in meters. This one must be in meter. Why this one must be in meters? Well, I'm saying millimeter. So EI is a millimeter. So I'm saying that whenever EI has any SI unit, every parameter should have that SI unit that EI carries. So EI now is in millimeter. So convert this meter to millimeter, meter to millimeter. When you are done with that, this is in Newton, not in kilonewton. So convert this kilonewton to what? To Newton alone. So now first task now, let's convert this one here. To convert meter to millimeter, let's convert 3.6 meter to millimeter. Multiply 3.6 by 1000 there. I'll have 3600 millimeter. All right, to convert kilonewton to Newton, that becomes 21 times 10 to the power 3, then Newton. Kilo is 10 to the power 3. So just replace kilo 10 to the power 3, then you have Newton here. Convert this one here to millimeter. Simply what? Multiply by 1000. 2.9 times 1000 there. I'll have 2900 millimeters. So I'm doing conversion here. All right, what's my next task here now? My next task is start solving. So let's calculate for this slope equation. So at this point here, so we're calculating for slope equation. So I have this formula here, which was derived from here. So next task now is putting value. So A is equal to, what's W? W there is 21 times 10 to the power 3 multiplied by L1 is of course 2900 all squared. So all over 2 times what's EI there? That's 9 times 10 to the power 12. If I multiply numerator, I'll have 1.7661 times 10 to the power 11 all over, multiply denominator, I'll have 1.8 times 10 to the power 13. Divide these two together. My slope equation A is equal to 9.811 times 10 to the power 23. Of course, in what? In radian. This becomes my answer to this question here. So let's get the last question done. That's why. Let's get deflection equation. All right. At this point here, deflection equation, let's dive into calculating for deflection equation. What do I get? We said that y was equal to what? WL1 squared over 2EI plus WL1 cubed over 3EI into L minus L1. So now the task is quite simple. I'll have that y is equal to what's W? W there is 21 times 10 to the power 3 times what's L1? That's 2900 all squared all over 2 times what's EI? That's EI there is 9 times 10 to the power 12. I'm done with this first one here. Plus what's W? That's 21 times 10 to the power 3 times what's L1? L1 is 2900 all to the power 3 all over E. That's 3 times EI. 9 times 10 to the power 12. So into what's from here what's L1 from here? What's L? That's 3600 minus what's L1? That's 2900. So from here, simplifying this one here alone, I'll have that answer there. Y is equal to, what is here is what is there. So I'll have 9.81 times 10 to the power 23 as the answer to this one here. So plus, let's get this one done. So let's get the answer to this one here. So 21 times 10 to the power 3. So multiplied by 2900 to the power 3. So divided by 3 times 9 times 10 to the power 12. So for this one here, I have 1.536 times 10 to the power 27 into simplify this one here. I'll have 7 that's 700 per se. So I minus 3600 minus 2900, that's 700. All right, add these two together here, so that y now is equal to 9.81 times 10 to the power 23 plus 1. All right, once you add these two up, this one and this, I'll have this value then into 700. Multiply 700 by this answer here, I'll have this as my answer to that question. So if you found this class helpful, do what you like, leave a comment, share to friends and classmates so they can learn too. See you in our next class.